All right, back to our word problem here. We finished this up in the last video, and now we're going to do a practice problem. So use the model from example 3 to find the value of x so that f of x equals 155. Explain what the solution means in this situation. So I want you guys to try that problem. If you have questions, of course, find me on Google Meet. All right, so the Edpuzzle will stop here. Here is the solution. So x equals 4 in 1999. 4 years after 1995, the wolf population will be 155. All right, if you have questions, you know where to find me. So families of functions. A family of functions is a group of functions with similar characteristics. For example, functions that have the form f of x equals mx plus b constitute a family of linear functions. Everything that we've worked with so far has been linear functions. It means that when we graph them, they show up as a line. This is another way to view graphs of lines, and also another way that can maybe help you graph lines. If you don't find this extremely helpful, then it's not something that I would emphasize as something that you need to know deeply. It's just more of an idea that can be helpful. So the most basic linear function in the family of linear functions, called the parent linear function, is f of x equals x. Another way to think of this is it's a line with a slope of 1, because this is like 1 times x, and a y-intercept of 0. Because we can also rewrite this f of x equals 1 times x plus 0 is another way to think of it. And so this is what the book considers, and other people in the math world consider the parent linear function. So the graph of the parent linear function is right here. So graph the function, compare the graph with the graph f of x equals x. So we have x plus 3. So the blue line is our parent function. Red line is x plus 3. We can see it has the same slope because they are parallel. And we can see that its y-intercept is 3 because it crosses the y-axis at 3. Because the graphs of g and f have the same slope, m equals 1, the lines are parallel. Also, the y-intercept of the graph of g is 3 more than the y-intercept of the graph of f. So you could just say it's like the line moved up 3, would be one way to think of it. For the next line, we have h of x equals 2x. So we could see that it both cross the y-axis at 0, giving us a y-intercept of 0, so it's just plus 0. They don't write that right, because mathematicians are lazy or efficient, however you think of it. But the slope here is 2, so it's going to go up 2 for every 1 run. Here it goes up 1 over 1. So run 1, or rise 1, run 1, rise 1, run 1. Here it goes rise 2, run 1. So because the slope of the graph of h is greater than the slope of the graph of f, the graph of h rises faster from left to right. The y-intercept for both graphs is 0, so both lines pass through the origin. Just to clarify, I'm not expecting answers this detailed for questions like this. If you're doing this in the book, you can just say slope steeper, line steeper, same y-intercept. Like something like that. A couple bullet points is fine for me. The main point is I want you to comment on the slope and the comment on the y-intercept. Right? So comparing graphs of linear functions with the graph f of x equals x. So changing m or b, or changing the slope or the y-intercept, in the general linear function g of x equals mx plus b creates families of linear functions whose graphs are related to the graph f of x equals x. So g of x equals x plus b. So this is all the lines that have a slope of 1. They just, instead of putting mx, they just put 1x here. Well, we don't write 1x because, mathematicians, lazy, you know that business. But you can see all the lines are just parallel, just like the first example there. They're all parallel. They're just moving up and down the y-axis. Over here, we have mx where m is greater than 0. So this is all numbers greater than 0. So this line does not have a slope greater than 0. This one does. This would be a steeper. This is 2x.